So we got our Unit 5, Lesson 1, so we're flying along, that's good. Okay, so just an overview. In this unit, we're going to study algebraic expressions called polynomials. Remember, we talked about Math10. We have monomial, that's like 1, binomials 2, trinomials 3, and then polynomial was 4 and bigger. That's how we classified them last year. But anyways, so that was kind of a quick refresh. In algebra, a letter represents one or more numbers. It's called a variable. So we're familiar with variables. Variables A, B, X, Y's, etc. Here's what I just pretty much just said, so that's good. A monomial is 1, like 4x. Binomial is 2, x plus 4. Trinomial, x squared plus x plus 4. Okay. Just not going to read that to you. If you want to read that, you can. Okay, so consider the following algebraic expressions. In each case, state whether expression represents a polynomial or not. Okay, if the expression does not represent a polynomial, explain why. And if the expression does represent a polynomial, state whether it's a monomial, binomial, or trinomial. Okay, so part A. Is this a polynomial, yes or no? Yep, it is. Good. It's got a variable. Okay. So yes, the polynomial. And then which one is it? Is it binomial, monomial, trinomial, or is it polynomial bigger than 4? Binomial. There's two things, okay? You have 1, you have 2, so it's binomial. Binomial, yeah. Okay, so let's go back in case I kind of skipped over just to refresh. Polynomial is it's a sum or difference of monomials. Okay, so that's where it gets kind of weird. A monomial by itself is not a polynomial. You have to have a addition or subtraction of monomials. So see right here, we have a subtraction of 2 monomials. But here, what do we have? Yeah, there's no addition subtraction. So this whole chunk right here is just a what? A single monomial, so it's not a polynomial. So this is not a polynomial because there's no sum or difference of monomials. Does that make sense? Sort of. I would say the first thing you need to look for having a polynomial, you need to look for plus and minus signs. You also need plus and minus signs, like right here. This is one package, so it's not a polynomial. Over here, yeah, they're ugly, but there's a minus, a plus. I feel pretty good about that. Plus, minus, I feel pretty good about that. This one, there's no plus or minuses. It's probably not feeling good about that for being a polynomial. Okay, so part C, it is a polynomial. Because I have, that's a monomial, that's a monomial, that's a monomial. I'm adding, subtracting 3 of them. So yes, polynomial. And it's what kind of polynomial? 1, 2, 3, trinomial. Oop, I might have lied on D. Well, I didn't lie, I said it didn't look. Okay. Polynomials do not work. This is kind of new, actually. Polynomials, your exponents have to be positive integers. So integers, what kind of numbers are integers? Right, but what's the definition? Positive or negative? Whole numbers. Okay, so we see the point 2 that cancels this not being a polynomial. So this is a non-polynomial. Non-polynomial, and exponent 0.2 is not an integer. Positive integer even. And that's why E doesn't work as well. How else can I write E without a fraction? Use your exponent rules. How can I move the A up? If it's a positive one here, I moved it up, what would it be? Good, it'd be a negative one, right? So that's a negative integer, right? And it's a monomial, so this is also a non-polynomial. Non-polynomial, because it's a non-positive integer. and also it's just a single monomial. So I guess that's the same thing here. Okay, sorry, let me change one thing here. Okay, sorry. Monomial, my bad. Monomial is a polynomial, I'm sorry. So if you want to change that, that's my bad. It is a polynomial, which I knew that, it makes sense. Monomial is a polynomial, but the reason that these ones didn't work, all the ones we canceled, is because in order to be a polynomial, they have to have whole positive numbers for exponents. So that's not whole. These are, that one's not, and this one's up being a negative. So that's why all three are not a polynomial. I apologize. Okay? Tricks of the trade going through the first book. First time through the book, I mean. All right. Let's get down here to example 2. Any questions on that since I kind of, hopefully I didn't confuse you too much? Okay. All right. So example 2. So let's complete the following table. Okay, so, all right, so let's go around here. So Tatum, how many variables are in the first one? 3. How many terms? Remember, terms are, no, it's plus, right? There's 1, 2, right? And so what we call this then? Binomial, right. Okay, good. Okay, Brandon, this guy? 1, 2, 3, good. Terms, and you call it trinomial. Good. Okay, Xander? How many variables? 1, good. How many terms? Good. And you'd call it a trinomial. Good, good, good. Josie? 1 variable. 1 term. Good. Okay, and Alex? 2 variables. 4. Good. 4 and up, we call this a polynomial. Good. Very good. Perfect. See, I didn't mess you guys up that bad. All right. Okay. So classifying polynomials by degree. What's the degree stand for? Exponent. Good. Okay. Polynomials can also be classified according to degree. The degree of a monomial is the sum of the exponents of its variables. So the tricky part, remember you guys, a lot of people mess up with Math10 with this. When you have 2 variables, the degree you have to add A's and the B's highest exponent. Okay. So this one here has a degree of 5. Okay, and then this one here has a degree of what? 6, right? The A is a 1. So 3 plus 2 plus 1. So a degree of 6. Very nice. Okay, and this big guy has a degree of what? 5? 4? Yeah, because it's per section, right? Here's a 4. That's a 4. That's a 5. So 5's the highest, right? Good. Good. And down the bottom here, if a polynomial has a term degree of 0, which just means there's no variable, because remember, anything with 0 power equals what? 1. So that makes the constant term. So what's the constant term in this list? What's a piece without a variable? -2. Okay. All right, I'll fly through these ones, and then we'll get back to, we'll go hit breezy and go back around here. So give an example of binomial with a degree of 1 with 1 variable. That would be like x plus 3. It's a binomial with a degree of 1 with 1 variable. These are just examples. A trinomial in 2 variables with a constant term. So x plus 4y plus 5 is the example I have in my notes here. So it's trinomial. I have 2 variables, and my constant is what? 5. Good? Okay, a monomial with a degree with a 6 with a numerical coefficient of 9. What's coefficient mean again? Yeah, in front of the variable. Good, Brandon. So 9, and I think on mine I went with, I put an A, but I don't want like 9s and A's. Let's go 9x to the 6th. Again, these are examples. You could do tons of things. I'm just putting examples. Okay, the last one here, a binomial of degree 8 with each term containing 2 variables. Okay, so I could do a couple of things. I'll do kind of easy, x4, y4, there's my 8, and then I'll do minus 2st plus rq squared. Oh, sorry, did they binomial? Oh, my bad, I got carried away. I want to add my own. Okay, so binomial with 8, 2st, yeah, there we go. Containing 2 variables, so we do want to stay, I got way too carried away. I want to stay with xy as well. My apologies again. x4, y4 minus 2xy. Yeah. Right, but that represents the area's equation, so like the answer can't be negative. Okay. All right, 267. And yeah, we're almost there. Okay, polynomials with single variables. So usually arranged in ascending order. So it's always nice to have your x squared first, your x second, your constant third. So you always like to go in ascending order. Okay, and descending order. It's usually how things are written. So like for example on this one, I'd like to put the x cubed usually first, with the x squared second, x third, the constant last. Okay, so remember descending means decelerate, so you're slowing down. Accelerate means you're writing them like from smallest to biggest. So for example, like I said, for descending, which is how you're going to see a lot of in your books when you're doing all your factoring and stuff, is 4x cubed plus 6x squared over 5 plus 2x minus 7. That would be descending. So we're going 3, 2, 1, 0. Ascending would just be the opposite. Negative 7 plus 2x plus 6x squared over 5 plus, minus 4x cubed. State the leading coefficient. So what's the leading coefficient of this polynomial? Yeah, so it comes from the x cubed, and it's the negative 4. Okay? The negative 4 is your leading coefficient. That's the coefficient in front of the biggest exponent. That's what makes it leading. Okay? The constant is what? Negative 7. Good? State the numerical coefficient of the term in the x squared. It's a fraction. 6 over 5 is your coefficient for the x squared. Okay. All right, we'll just briefly go through the algebra tiles again. You guys know from last year they had me, like the algebra tiles are just kind of a visual representation. You don't have to have them. You don't have to use them. Okay, so remember shaded. Okay, so shaded's positive, unshaded's negative. Okay, one little box means 1, a line means x, and the whole thing's x squared, a square. So it says state polynomial expression which describes each diagram. So this would be a negative x squared plus 2x plus 1. Okay, because I have a square that's white, which is a negative. My two lines of x's, a positive and a positive unit. Okay, this one, I have 2x squareds that are positive. What happens to these? Cancels, cancel, cancel. I'm left with negative 1. Very nice. All right. addition, subtraction using algebra tiles. So, alright, so we'll just do this once or twice here. So use algebra tile to determine the result of the addition of the following. So if I had 2x squareds, they'd be shaded. And then plus a unit, so it'd be one shaded unit. And then I would add that to shaded x squared, and then 2 x's, unshaded, white, and then 3 negative units. So the best way to do this is kind of like group. So I have 1, 2, 3 x squareds. I don't have any x's. I'm missing 2 x's. So these are done. I have 1 positive, 3 negative. That leaves me with 2 negative. Okay. Alright, I'm going to, well, we can do it, it's fine. One more time, one more algebra tile example, and I think that's it. Alright, so subtract polynomial equivalent to adding inverse polynomial, okay. So all this is doing is actually I'm not going to do algebra tiles for this. All this is doing is when you're minusing a group, what happens? Right, you add the opposite, okay, or the negative hits everything, right? So it just kind of changes, like he said, the opposite. So you can go change the minus to plus, that's a negative. That's a positive, that's a positive. So we're really going negative x squared plus 3x minus 2 minus 2x squared plus x plus 1. And we have to combine like terms. So combine like terms, I have a negative 1x squared, a negative 2x squared, so negative 3x squared, 3x and a 1x, so 4x, negative 2 and 1 is negative 1. So that would be your final answer on that one. Okay. All right, last two things. Okay, addition, subtraction of polynomial expressions. So we're adding polynomial expressions. So we get here, we're just putting, it's just simply, I always call it combining like terms. Okay, there's no reason to think of it anything different than that. You're combining like terms. So I have 3 A's. Over here, I'm adding negative 3A's. So essentially, those ones what? 3 plus a negative 3? They're going to cancel, right? I have a negative 4B plus 3B. That's a negative 1B. So I'm done with those. C plus a negative 5C is a negative 4C. So your A would be negative B minus 4C. Part B, if you like writing stuff vertically, good organizational tool if you'd like to try that. You can simply just go 4 minus 2, which is 2x squared. Negative 9 minus a negative 3, which makes it a plus 3, negative 6x. 6 minus a negative 1 makes it a plus 1, so you get a plus 7. Okay, just combining your like terms. Sorry if I'm going too fast. Let me know if you need any questions. Just doing a vertical addition subtraction of like terms. All right, last two. Okay, so the key here is, it's good to use the highlighter on this one to try to highlight your like stuff. So 4x, negative x. So I have a 4x, negative x, that makes a 3x, 4x minus x, essentially. Okay, go back to here. We got negative 2x squared and a negative 6x squared. So negative 2 minus 6, negative 8x squared. And then lastly, we have 3 plus 5, 8. Okay, I always like, it's good practice to write stuff in descending order. So I would write your x squared in front, like so. Okay, and last one here, a squared b 5a squared b. So 1a squared b plus 5a squared b, I have 6a squared b. Negative ab squared and a negative 7ab squared. Negative 1 minus 7, negative 8. And then this one's by itself, so it stays the same. And that's as simple as it gets. In terms of descending order for this one, it just depends what variable you want to use. So if I want to do descending with a's, then I put the the a3 first, second, third. So like this, with the a3, the a2, and then the a1, like that. That would be descending order in terms of a. Okay, that was just kind of the review, preview, hopefully.